I am the Tofu Golem. Please enjoy the video.
You begin by ensuring your CP/M environment is live and reachable. Log in and verify permissions. Once done, install the required tools: a compatible compiler, a lightweight debugger, and a reliable file transfer utility so you can move builds quickly. Next, prepare a minimal source template and a matching config file with target addresses and memory layout defined. Make sure to save backups. You must start with a clean, reproducible baseline so subsequent steps produce consistent, testable Diz artifacts. Now implement the core Diz algorithm inside the template, adding explicit memory handlers and boundary checks to avoid corrupting CP/M structures. Compile with optimization flags suitable for your target, then run unit tests locally to validate logic and memory behavior. Once tests pass, integrate the compiled binary into the CP/M image or file system, update boot and config entries so the system recognizes the new component, and perform an initial cold start. Make sure to log build artifacts and config diffs for traceability. For finalization, perform a full functional run of Diz in the CP/M environment and monitor logs and resource usage to validate outputs against expected behavior. If something goes wrong, capture logs immediately, reproduce the issue with increased verbosity, and isolate the failing module to narrow the root cause. Apply a focused patch, retest the sequence end-to-end, and document every change. Once results are stable, roll forward the update. A single key tip: if timing-related faults appear, add instrumentation to reveal race conditions.
Thanks for watching. Consider subscribing if we helped you today.